All right, my brothers and sisters, we're finally at the end. Problem 6. Given the functions f of x equals sine 2x and g of x equals cos squared 2x, answer the following questions. All right, calculate the instantaneous rate of change of g at x equals pi over 4. Show your steps. Instantaneous rate of change means the derivative at a point. So what I need to do is find the derivative of g, and then once I do, plug in pi over 4. Now g is cos squared 2x. I'm going to rewrite it like this because it helps me understand it better, because I'm going to be applying chain rule to this guy. So we have cos 2x squared. Now chain rule says that we take the derivative of the outside, which means we drop the 2 in front, right? Make that an invisible 1, which we'll clean up in a bit. Obviously, we have got a lot going on here. Keep the inside stuff, which is cos 2x, and then multiply everything by the derivative of the inside stuff, which, fun fact, is going to be chain rule yet again. So the derivative of the inside stuff is going to be negative sine, because we're taking the derivative of cosine. Keep 2x, but then multiply everything by the derivative of 2x, which is 2. All right, so what we end up with is g prime is going to equal, we can throw that negative out there, we can keep that 2 times 2, which is 4 out there, and then we have, since that's the invisible 1, cos 2x sine 2x. Now, I need to plug in pi over 4. So g prime of pi over 4 is going to be negative 4 cosine. Now, 2 times pi over 4 is pi over 2, okay? And sine 2 times pi over 4 is also pi over 2. Cosine of pi over 2 is the same as cosine of 90 degrees, which is a big fat nothing. And sine of pi over 2 is going to be, well, who cares, because all of this is just going to be 0. So the instantaneous rate of change at x or pi over 4 is 0, which means the tangent line is a flat horizontal line. Fun, 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 fun in the sun. Fun, fun, fun in the sun. Okay? Show your steps. I did. Let's go to B. Find the second derivative of f of x, denoted as f double prime of x. Show your steps. Well, f of x is sine 2x. The derivative with respect to x is chain rule. Take the derivative of the outside, which is cosine. Keep the inside, which is 2x, but then multiply everything by the derivative of the inside, which is just 2. So f prime of x can be cleaned up and turned into 2 cos 2x. F double prime is the derivative of what we just came up with. So 2 still lives there. Cosine is going to become negative sine. Take the derivative of the outside, keep 2x, which is the inside, and then multiply everything by the derivative of the inside, which is 2. So very similar to what we saw over here. Very, very, very similar. But this cleans up to f double prime of x equals negative 2 times 2, so negative 4 sine 2x. Okay? Show your steps. I did. I just did. Now onto the hammer. Okay? Calculate the area under the curve of f of x over g of x. So before we do anything, okay, let's find out what f of x over g of x actually is. And we'll do that over here. F of x over g of x is going to be sine 2x over cos squared 2x. Now that 2x is gold because that tells me we can simplify stuff. What I could do is I could rewrite that out as sine 2x over cos 2x, and then over here I basically have 1 over cos 2x. That's what sine squared 2x means. I mean, I wrote it back in part A that it's the same thing as cos 2x, all of it squared. Now u becomes sine over cosine, which is tangent, 2x, and u become 1 over cosine 2x, which is secant 2x. So what it's asking me to do is calculate the area under that curve. Okay, so to calculate the area under the curve, that is going to be an integral. And we're going to integrate it from 0 to pi over 6. Okay, show your steps. So I'm going to integrate from 0 to pi over 6 tan 2x secant 2x. Now, there's a lot of ways you can handle this, okay? I just so happen to have it memorized that the integral of tan x, okay, and this is just a fun fact I'll write off to the side, the integral of tan, and we'll actually do this, tan u secant u du happens to be secant u, plus c technically, but whatever. Okay, that's a little rule. So I know all of this will eventually become secant. However, that 2x is not x. I can't just apply that rule. So what I have to do is I have to do u substitution. So I'm going to let u equal 2x. Now this isn't that bad because then you do the du dx, the derivative with respect to x, and that's just going to be 2. And I need to find a way to replace that dx, so I'm going to multiply dx divided by 2, and then dx is going to end up being du over 2. So simplifying this a little bit, I have the integral, okay, as x goes to 0 and x goes to pi over 6. I have du over 2, so tan, first off, 2x is now u, so tan u secant u du over 2. Basically, pull the 1/2 out. So to pull the 1/2 out, my limits are still x is going to 0, x is going to pi over 6, and then I have tan u secant u du. And according to what I just wrote right over there, that is going to become secant u, where my x limits are still pi over 6 and 0. Let's substitute what that actually is, and let's kill 2 birds with 1 stone. I could bring that 2 back out, that 1 over 2 back out. Okay, secant is cosine, and u I called 2x. So I'm going to write it out like that. Okay, so what I do now is I'm going to plug in pi over 6. So 1 over 2 cos, 2 times pi over 6 is pi over 3. And I'm going to subtract me plugging in 0. 1 over 2 cos, 2 times 0 is 0, so cos 0. Cosine of pi over 3 is 1/2, so you're 1 over 1/2, and cosine of 0 is 1, so minus 1 over, oh, did I forget something? I did. 2 times 1/2, oh boy. So 1 over 2 times 1/2, that would change things. Over 1 over 2 times cosine of 0, which is 1. So I get, and hopefully this doesn't get cut off when I make the video, it shouldn't, 1 over half of 1, or half of 2, which is 1, minus 1 over 2 times 1, which is 1/2. And when the all is said and done, I get 1/2. That, ladies and gentlemen, is it. That is the Math Teacher GOAT Ultimate AP Calculus exam, beginning to end, soup to nuts. I hope you enjoyed it. Share this with all of your calculus friends. Thank you for watching. I love you. Bye.